everyone. Whoa, I love that one. Okay. Welcome to this session. In this session, we're going to talk about integration patterns. We're going to talk about serverless, and obviously, we're going to talk about microservices. So just a quick context about this session. I'm a principal developer advocate, and it's my role to talk to developers about their challenges and their pain points on building technology on top of AWS. And this is actually the collection of lessons and discussion that I had with developers across ASEAN. Like many of developers, they are building microservices, but they are still getting into a trouble and challenges on building distributed system. Now, a quick question for you. How many of you are developers? Good. How many of you are new to microservices? Okay, cool. So I believe this is going to be give you benefits on understanding what are the key elements that you need to understand to build distributed system on top of AWS. Now, a quick context of the motivation of my session is basically from Tim Bray. And this is something that he shared at TrainFan a few years ago. And he mentioned about if your application is cloud native, or large scale, or distributed, and doesn't include a messaging component, that's probably a bug. So that makes me realize that I think from the discussion that I had with developers, the most difficulties for them having a resilient system is about messaging. So that's something we're going to talk later on. And that's actually the key takeaway of my session. And in this session, you will understand the few fundamental integration patterns. I'm not going to talk all. There's so many. There's more than 65. But I'm going to give you like three fundamental integration patterns that you need to understand. And what are the AWS serverless services that you can use to implement these patterns, and how that you can compose your modular application using serverless microservices and implement the integration pattern into ISC and building CI/CD. Right? Okay, so we all been through this kind of discussion. Like we started with monolithic, and then we stepped up, and then we built service-oriented architecture, and we came up with microservices. So I will not dwell into the benefits. Oh, should I move to microservices? We're not going to dwell into that kind of discussion, but assuming that most of you already understood what is distributed system and what is the benefits of moving to microservices. But there is something that we haven't talked that much, and that is the complexities of microservices, right? Because within microservices, you have a lot of services that communicate one to another. And when you grow your system, definitely you need to add more features. That means more service. You need to add more domains. That means more services. And this communication can be becoming so complex. And we haven't talked that much. And this is something that I want to emphasize in this session. There are 4 things that we can do how to reduce complexities on microservices. So this is based on my discussion with developers across ASEAN. There are 4 things that we can do to reduce complexities. The first one is that we need to rethink about the operational model. Right. So when it comes to the infrastructure for distributed system or microservices, you're going to think about, oh, I have to build like a lot of servers. Yeah, that's true. But if you move to serverless, that's something that could remove the unnecessary heavy lifting for you. It will make easier for you to provision new services or new infrastructure for your microservices. Right. So the next part is the integration patterns. Because in microservices, we have service A, service B, service C, service D. We need to understand how to integrate them all together. Now, the third aspect is about automation, DevOps. Obviously, DevOps is really it's universe on its own. And in this session, I'm going to talk about ISC, infrastructure as code, and CI/CD. And lastly, is feasibility. It's all about observability and monitoring. Now, because we are kind of a bit short in terms of the time, I'm going to cover 3 aspects, and that is serverless, integration patterns, and DevOps. Right, so imagine that you are building an e-commerce microservices. It's super simple. We have a task to build a use case in e-commerce to process the order. So we have an order service that's going to receive all the requests, and this order service needs to pass the request to invoice service, fulfillment, and also forecasting service. So in total, there are 4. Right? There are 4 services that we need to build. And we zoom out, we can represent all of those services as a box. So let's call them as service A, service B, service C, and service D. And these boxes, they represent on how we host application. Now, the next question is that, what is the best compute option for my workload? That would be your first question. Now, this is something that I want to share with you about serverless. Now, with AWS, you get this flexibility on choosing what kind of services, in this case, a compute services that suits your use case. And I just want to reiterate that if you see, we have Amazon EC2, we have Amazon ECS container service on EC2, we have Amazon ECS on AWS Fargate, and on top we have AWS Lambda. Right? So this is going to answer your first question, what is the best compute option for me? Right. Now, what I want to emphasize is that on the right side, you can see what AWS manage and what you manage. Now, if you choose to use Amazon EC2, meaning that you have this flexibility, you have this granular control on what kind of infrastructure that you want to provision, which is good, right? And then if we see on AWS Lambda, you see less things that you need to manage. So these are the kind of options that AWS provides for you. If you don't want to handle all the infrastructure, you can just use AWS Lambda, upload your function, and let it run. But if you need to have this granular control on your infrastructure, then probably it's best for you to use Amazon EC2. Now, if we zoom out a bit, we can see that how serverless help developers focus on building, on delivering the customer's value within your application and not managing your infrastructure, right? So this is a kind of perspective that I want to share with all of you. Because with serverless, you have this flexibility, you have this agility to focus on creating business value. And it removes you from heavy lifting, like you don't need to start from scratch on deploying your application, you don't need to provision infrastructure, you don't need to do any other configurations. Right? So this is really the key to understand that on serverless, that it's not all about technology, it's all about operational model. Then this is one of the reasons why customers and developers are choosing serverless. They provide you with agility, they give you flexibility and productivity to speed up your development. It also can scale up and down based on the request. So it doesn't really care if it's a 10 requests that only your system getting in, or like up to like a 10 million requests. You don't need to manage everything. It's going to elastically scale up and down. And also cost effective, because with, for example, with AWS Lambda, you only need to pay for the requests when the function is being triggered. And also it comes with security. Now, if we use that kind of perspective, that serverless is not all about technology, it's the way that we think, how that we delegate the operation. Serverless is much more than compute, because we can apply that to many layers. Like for example, we have compute layer. You have this option. You can use AWS Lambda to run your function. You can use AWS Fargate to run your containerized application. Or in the next layer, you also have an option, serverless options. If you want to host your files or objects, you can use Amazon S3. Hey, what about if I want to use serverless NoSQL database? You can use Amazon DynamoDB. And it applies to many layers, especially in the integration, which I'm going to cover about Amazon Event Bridge, Amazon API Gateway, and other step functions. Right, so think about that serverless is all about operational model. It's not all about technology. It's all about to help you to focus on creating business value and not managing the infrastructure. And And serverless is the most common implementation in modern application. Whenever you see people building serverless application, you will end up to see that they are using a lot of services. Like on the right side, you can see that we have Amazon API Gateway, we have DynamoDB, we have AWS Lambda, we have Amazon S3, and probably many more. Right? And this follow the building blocks of the internet, that there are small pieces, but they are loosely joined. And you probably think that, oh, this is kind of a bit complex. Yeah, probably, but my argument is that it gives us the real intent of our architecture. Here you can see that we have Amazon API Gateway that trigger AWS Lambda and save to DynamoDB. Oh, we can also see that we have event bus on Amazon Event Bridge, and we have this S3 bucket. You can see the real intention on building application. Why? Because they are building blocks. We know what are the features of this service. Now, if we go back to the boxes that we have, service A, B, C, and D, there's something missing. And when it comes to microservice, something is missing is the interaction between these services. Now, this is the slide that I borrowed from Gregor Hope's presentation at re:Invent. And it's really amazing on how he illustrates this. Now, you can see that even with the same surface, but with the different direction of the lines, we can architect two different system designs. On the left side, we can have like a stack architecture, meaning that we have a sequential or a call from service A, calling service B, calling service C, and calling service D. But we can also have loosely coupled services, which is A calling B and C calling D, anything that we want it to be. Right. So this emphasizes that the lines is the integration between services is the key to create structure, and that will define your system performance. Right? Now, the magic word is coupling. Coupling is a measure of independent variability between connected systems. Now, the coupling has a cost, right? Both design and runtime. And something that I got questioned a lot from developers is that, is coupling negative? It really depends. If you have granular, if you have less control to the connected surface, so probably you prefer to have a loosely coupling. But if you have more control, then you can probably do more tight coupling. And then this is the quote from Gregor. And it's really fundamental for us to understand how to build a distributed system with modern application. And that integration is not an afterthought. It's an integral part of the application architecture. Right, so that's all about serverless. And then let's go to the messaging patterns. And the first patterns that I would like to share with you is about synchronous request response. So imagine that you're building e-commerce microservices. API is probably something that you use to communicate between these services. Now, like for example, we have a simple architecture. We have an order service going to receive all the requests from Amazon API Gateway. And we have 3 other services that needs to be called from order service. Right? So let's switch to the demo.
This demo is designed to illustrate the architecture shown on the screen. We have an order service, serving requests via HTTP API. To complete the request, the order service needs to make downstream calls to 3 services. They are invoice service, fulfillment service, and forecasting service. Once that the order service receives responses from all services, it will return back the response to the client. We are going to use Amazon API Gateway and AWS Lambda for this demo. And the idea is to illustrate the challenge of systematic calls using synchronous APIs if it's not handled properly. There are 2 scenarios in this demo. First scenario is the ideal scenario with the client calling the order service via HTTP API, and all downstream requests made by order service got 200 OK response from other services. This scenario is ideal if everything works fine. Let's take a look. We have 4 Lambda functions in this demo. There are functions for each service which shown on the diagram architecture. Nothing too fancy about the function. They only have to print out the event received into CloudWatch logs. And also we have timer there to help us simulate the second part of this demo. The order service is our main function and integrated with API gateway, as this is the public-facing API whenever a client needs to send an order request. Now, if we click this endpoint, it will return to us all the response from other services. And if we simulate the traffic using Artillery Toolkit with 100 requests, everything is still good with all requests returned 200 HTTP status code. All good, everyone is happy. Now, for the second scenario, we're going to add some changes in one function. The idea is to illustrate what happens if one service fails to complete requests in a systematic synchronous API design. Let's assume that the forecasting service needs to process a really complex scenario and it takes 30 seconds in average to complete a single request. And let's try to simulate again the traffic with Artillery tool. We're going to use the same config with 100 requests hitting the same endpoint. And let's see what's going to happen. As you can see that all requests, they end up with 504 HTTP status code, which means the request is timed out. And this is a classic challenge in a systematic synchronous API design. And you can do vertical scaling, increase timeout in API gateway, but that doesn't solve the underlying problem. It's the design.
See, the transaction failed. Imagine that somebody, your customers, wanted to order something from your website and the transaction failed. Hey, but I've built everything on modern stack. I'm using Amazon API Gateway, I'm using AWS Lambda and all of those cool services. So what's wrong? Something that's not right here is how that you architect the communication between service to another service. Now let's switch back to the slides. Now the answer to that kind of challenge is that we need to have the communication in asynchronous mode. Why? Because with synchronous mode, we're calling service A, calling service B is going to wait a response, calling service C going to wait a response, and what happened if the service C failed to return or process is going to make all the transaction fail. Now the key of that challenge is the asynchronous communication. Now you're probably wondering, okay, so asynchronous communication, that means that I can only use messaging. No. On this slide, you can see that you can also architect asynchronous communication using API. The way it works is that you hit service A, and then it's going to return the URL address and the correlation ID, which you can use to retrieve the status of those requests. But another approach that you can use is using messaging. So in this case, that you can use a message channel. So this message channel can be a point-to-point or queue, or you can use public subscribe using topic or event bus. Now, one of the most commonly used approaches is public subscribe or message bus. So the key difference between event bus and topic based is that topic is by domain and message bus is in the application context. Another key characteristic about this message bus is that all the services can be prosumer. They can produce event and they can also consume the event. Now the next question is that, okay, so I don't want to build this from scratch. What are the services that I can use that AWS already offer? And the answer is that Amazon Event Bridge. Now Amazon Event Bridge is really amazing service. Why? Because with Amazon Event Bridge, you can have all the services or all the events coming from AWS services. It will be custom events, it will be SaaS application, and then you can define your own custom bus and you can define the rules, and this rule will define which target that I need to pass the events. And everything without coding or any kind of integration or glue code. Everything is just need to have configuration between the source and the target. Now, to help you understand on how that we could solve the problem on synchronous communication, in this architecture, I re-architect all this communication. So we have still a synchronous call going to the order service, and the order service is going to put some payload to Amazon Event Bridge as the event bus, and it's going to pass the information to 4 services, like invoice service, fulfillment service, forecasting service, and logistics service. Now you can see that each service will process different events we have order created, we have fulfillment created, and we only have two, order created and fulfillment created. Okay, so let's see the demo.
In this demo, we're going to see how Amazon Event Bridge can solve the systematic synchronous API design challenge by changing the architecture with leveraging Event Bridge as an event router to handle the asynchronous communication between services. So this is how it looks like. Whenever order service receives request, it's going to publish an event called order created to Event Bridge. Event Bridge will then push the event to respective services which are being the target for the particular event. Furthermore, few of the services will publish their own event, and so Event Bridge will handle and push the event to the target services as well. Additional event that we're going to create is fulfillment completed by fulfillment service, which will be consumed by logistics service. So the idea is to have a complete data flow whenever the system receives order creation. Now, these are the Lambda functions that I use for this demo. You might notice that I've added few additional services, and these services will be used in this demo to demonstrate how scalable and robust if we build a microservices with asynchronous communication with event router. So it's more complex compared to our previous demo. One thing that I like to emphasize is none of these functions know the existence of each other and no link whatsoever. All the communications will go through Event Bridge as this function publish their own events. Okay, so moving on. The first question is how to publish the event to Event Bridge. Now this is a snippet code on how you can use AWS SDK, and this one is written in Python using BOA301. It's really straightforward. You only need to call putEventAPI and then fill the parameters such as source, detail type, and event bus name. The detail variable holds our payload, so your data will go there. And all of these parameters could be used when we want to define the rule in Amazon Event Bridge. Now let's see how I configure the Event Bridge to handle the event. Let's go to the rules section and select the event bus. On this page, you can see that we have few rules for each service. We have fulfillment service, invoice service, logistics service, and notification service. Let's take a look into one of these rules. One of the most important components in Event Bridge is event pattern. Whenever it receives an event, it will match the event with the pattern that you have defined before routing the event to the target. Now in this context, if the detail type contains fulfillment completed, it will go to the logistics service, which is exactly what we want to have. So whenever the line items are fulfilled, it goes to logistics service to deliver them to customers. So if we go to fulfillment function, we can see this function publish the fulfillment completed to Event Bridge. There's no downstream call to logistics service, it only publishes an event. And also, let's change the sleep time to 30 seconds, same with our previous demo, and to simulate the fulfillment service takes 30 seconds to complete one request. Similarly to our previous demo, the flow is started whenever we hit an API request, and the order service is our public API and integrated with Amazon API Gateway. So if we open this endpoint link, it will give us HTTP OK status code and an empty response. So let's test it out. This is our dashboard. Nothing too fancy over here. It's just to give us an info from our backend whenever it completes processing. So when it completes something, it's going to update this dashboard. Whenever we make an API call to order service endpoint, the order service will publish an event to invoice service, so it could send the invoice to the customers. The event that the order service publishes, it will also be consumed by the fulfillment service. Now, remember that fulfillment service takes a bit of time, around 30 seconds to complete the request. And once it completes the request, it's going to publish another event, which is logistics started, and it will be consumed by logistics service. And that will be indicated in this column that it's shipping to customer. Okay, cool. So let's start this demo. Let's use artillery tool again to create 100 requests. As you can see, the order service is now updating. And invoice service is being called and send the invoice as well. Good. Now the fulfillment service is trying to complete the job. And you notice once that the fulfillment completed, it's shipping to customers as well. And now all requests were handled properly, no timeout, quite fast I should say, and everyone is happy. And that's how you use Amazon Event Bridge to choreograph asynchronous communication between microservices.
Now, the next patterns that really useful for you is called pipes and filters. Now, pipes and filters in easy word is as simple that you have an event or you have a payload that you need to process. Then you probably need to filter out some of the events that you don't want to process. And then you need to do some processing until the processing is finished as what you intended to be. So that's the easiest explanation about pipes and filter. And to implement this in Amazon Event Bridge, you can use Amazon Event Bridge pipes, launched last year at re:Invent with Amazon Event Bridge pipes that it has give you flexibilities to get the source, what kind of events, and then you can also do filtering, filter out all the message that you don't need. You can also do enrichment. Like for example, sometimes you need to get more additional context to your payload and then send it to the target. Now, with Amazon Event Bridge pipes, you can, for example, connect your SQS to AWS Step Functions, connect your SQS or even from DynamoDB streams, and reach it with API destination, which is external API, and then process it with Step Functions. The bottom line is this: with Amazon Event Bridge pipes, it helps you to enrich your data in your serverless microservices. Now, the next pattern that I would like to share with you is Saga orchestration. Now, when it comes to microservices, we have a lot of services that are doing A, B, C, and D. Now, at some point, you will need this kind of use case that you need to process them sequentially as a workflow. Now, the service that you can use within AWS is called AWS Step Function. And this is a really cool service because with AWS Step Function, you can orchestrate your workflow and integrating with any kind of AWS services. My favorite is AWS Lambda. Now, one example to do that is that this is the example of Saga pattern. Like, imagine that you have this still in e-commerce process that you need to send out the items to your customers. First thing that you need to do is that you need to check the inventory. If the inventory, you have this item, and then it's going to go for the payment. If the payment is okay, it goes to the logistic, and if the logistic is okay, then it's going to mark the transaction as success. But what happened if one of these service went wrong? So what you can do is that you can do rollback using this Saga pattern and AWS Step Function. Okay, so we talked about various integration patterns. We talked about PubSub using Event Bus. We talked about Saga pattern. We talked about pipes and filters, right? Now, you're probably wondering, okay, so which patterns is going to be useful for me? Now, the good news is that you can mix and match these integration patterns. Like in this case, we have a synchronous call using API Gateway. We have this event bus using Amazon Event Bridge, and we also have the implementation of Saga pattern on payment processing using AWS Step Functions. So please use the right service for your use case. Now, the last thing that I want to share with you is that how that we could compose everything together, and the key for that is AWS CDK. Now, I'm not going to talk much about this. I'm going to show you a demo on how it looks like. So basically, the workflow we're using AWS CDK is that you define the source code, you use the construct, you integrate the services, you implement release pipeline, and then you run. Now, there's something really cool about AWS CDK that I would like to show you. Let's switch to demo.
In this demo, we're going to integrate our application with CI/CD. We are going to reuse the serverless API application that we reviewed in the last demo. But now we're going to build a release pipeline using AWS CDK pipelines for our application. As we are going to use an external repository, and that is GitHub, we need to create connection first so we can easily reuse the connection for our CDK pipelines. Let's head over to the Developer Tools dashboard and go to Settings. Under the Settings, you will find Connections. Here, I already have a GitHub connection established. And if you haven't created one, you can easily create the connection by clicking this button. give it a name, and it will redirect you to GitHub page for authentication and authorization. Once that you have established the connection, you will need to copy your ARN and save it for later use. In this case, I'm storing the connection ARN into SSM parameter store so I can retrieve it later on my CDK application. With that out of the way, let's review the project folder structure. Here, we have same folder structure just like what we have for previous demo. We have Lambda functions to host all of our Lambda functions. They are our main applications to implement serverless API. And we also have CDK folder here. Now, if we open the main CDK application, we can see that it's slightly different with the CDK app in previous demo. You can see that here we have included two other libraries, and they are AWS SSM, which we're going to use to get the GitHub connection ARN from parameter store. The other additional library that we are going to use in this demo is CDK pipelines. And we imported that library on this line. And this section is our serverless API stack. I'm using the same codes like the previous demo, so there's no changes in the app itself. If we scroll down below, we see how we construct the application. Here we define my AWS account ID and the region, which we are going to pass into the pipeline environment. And this also means that you can use multiple accounts to deploy your application. The practical use case for this is using one account to host your production-ready environment and the other environment for staging. By having separate accounts, we are isolating the resources. And this is super cool, as we can easily manage deployment to multiple environments using multiple accounts, simply by defining these lines. The first thing we need to do to implement CI/CD is defining the pipeline stack and passing the end variable. As we are going to integrate with GitHub as Git repository, I need to get the GitHub connection ARN, which I stored previously in AWS SSM parameter store. And it is worth to mention there are various ways to use GitHub with CDK pipelines. For an example, you can use AWS Secrets Manager. This demo uses developer tools connections, as we can reuse it for another purpose. Then we define the pipeline object and the build stage. The build and synthesize stage in this tutorial is using the shell step. Here we have the input to get the source code from my GitHub repository called demo CDK using main branch and reusing the existing GitHub connection that I already have. Then these are the comments that I need to run on the build stage. I need to install CDK, install all requirements with pip, then perform CDK synth to generate CloudFormation template and set the output to cdk.out folder. At this stage, we have defined the build process for our application. In the next lines, we will define the application environment, our stages. In this case, is staging. Okay, we're done here. Next, we need to deploy this pipeline. Before we do that, we need to commit and push our changes into the Git repo. Once that we have pushed all of our codes, now it's time for us to deploy the CDK. And we only need to do this one time. And for the subsequent changes, we only need to push our codes. And this is a powerful feature in CDK pipelines, which it will self-mutate and perform any changes. And I will show you later in the next demo. Once CDK finishes processing, we can check the pipeline in the code pipeline dashboard. As you can see, we have a nice CI/CD integrated with our application. CDK pipelines automatically create this release pipeline for us, from getting the source from Git repository to build the application and deployment into our environment. And if we click this link and go to the CloudFormation dashboard and go to the output tab, we can see the resources created by CDK, especially the API with URL. And if I just do a quick test, we can see that's running properly. Now at this stage, you know how to integrate your ISE and CI/CD using CDK pipelines.
All right. Okay, so let's switch to the slide. Okay, so I think that's all that I have for today. Obviously, there are more stuff that I cannot share with you, but it's going to be covered by these two amazing guys. We have building open source observability platform with AWS by Ali. And if you're interested on learning about chaos engineering on Kubernetes, you can join Farhan's session later also in this track. And for those of you who want to upskill your cloud skills, please join skillbuilder.aws. We have a lot of materials for you. You can access it on demand, and this is going to be useful for you to learn about cloud computing and AWS. And that's all from me. Thank you so much. We are hoping that get your feedback so we can improve for the next event. Thank you.